Hello, my name is Brian Lim, and I'll be presenting to you today about visual chain of thought for controllable image captioning. Before I get into what the visual chain of thought is, first I want to introduce to you what controllable image captioning is. Controllable image captioning is an extension of traditional image captioning that augments the generated caption based on user input. That user input can be a text dialog, text prompt, or some sort of visual control that allows the user to select a specific area of the image to focus the caption on. For example, on the right, the user might want to focus the caption on only the yellow fish, so they might select the yellow fish and ask the captioner to generate a caption only for that, as opposed to the entire image as a whole. The visual chain of thought was introduced by the Caption Anything model, and it is a technique used to get the models to focus on the desired areas of the image. It does this by doing a step-by-step process of generating the caption first, so that it identifies the object that the user is desiring to caption it for, and then it generates a caption for the desired object. This visual chain of thought is where I spent my project and ran my experiments, seeing how important it was to the generated caption to create those focused and detailed captions, as well as if there are any ways that it could be improved by adjusting how it's cropped when the background is included or not included, or the text prompts used for the captioner. The visual chain of thought works by first cropping the image to the bounds of the segmentation mask used, and then also removing any of the background from the image, from that cropped image that is not as part of the segmentation mask. It then passes this cropped and background removed image to the captioner to identify the object that is desired to be captioned. Based on that output, it then puts the background back in the image and prompts the captioner again to describe that object within the context of the background of the cropped image. And that's the generated caption that ideally will be focused. For my experiments, I tested out different text prompts and background modes. And for each of those experiments, as well as a baseline of both the baseline visual chain of thought implementation and a baseline captioning implementation without the visual chain of thought, each of those different implementations were set through a data set of 100 images, where each image had 5 segmentation masks generated for a total of 500 segmentation masks for each implementation that we used to evaluate them. To evaluate quantitatively, I leveraged the clip score, which is a reference-free metric that measures the correlation of a generated caption to the contents of an image. Interestingly, my experiments showed that there does not appear to be a big performance gain when the visual chain of thought is used, as opposed to just a baseline captioner without a visual chain of thought when you just crop the image around the segmentation mask. We see that that baseline without actually performed the best across those 500 segmentation masks as measured by the clip score. And this seems to show that the prompts don't seem to be focusing the model more than the cropping. Qualitatively, we see this example where on the left is the image of a soccer player and the segmentation mask of the soccer player's jersey. We see that the baseline without visual chain of thought and with the visual chain of thought both generate very similar captions, while the different prompts and techniques tested had a harder time focusing on the desired area and generating a relevant and detailed caption. Thank you for your time listening to my presentation.